note the different types where it will occur, and then we will come to the hydrocarbon potentiality part. So I have divided my this deliberation into three parts. One is your about your sedimentary basins, how sedimentary, what are the sedimentary basins normally we are studying, and number two, with respect to our uh, solid and liquid fossil fuel. That means, though I am from your coal or lignite, that means solid fossil fuel, but hydrocarbon potentiality does not mean only solid. It may be gas, it may be liquid. So, what are those, and what are the things going on in our GSI or in India right now? So, about them. So, this is one part, and another part is there that that how this hydrocarbon potentiality maybe increased in future, or what are the potential sources that we should find in future. So some basics will be there, that just to reconcile yourself, that I know that these things. It is just the interaction, and for remembering the earlier things, and that's why I have separated these things like that. So first I am going to the sedimentary basins. Now you know that basin is a sag or depression on continental crust or oceanic crust. Now the main six types of sedimentary basins are there. So these basins are just tell me this. These basins are the French, and the setup of this plate tectonic settings. The divergent margin, the convergent margin, everything. And about that, we know that six types of major sedimentary basins are there. Starting from the subduction part, it will be a trench. Then we know the arc system over there, and before arc there is a fore arc, and beyond arc there is a back arc or foreland type of things. This is fore arc, foreland or back arc, almost same, and this is one arch. Beyond that it is intracratonic, that means within the craton. Then the passive margin of the craton, that means that is going to the again to the ocean, so that the continental shelf, continental slope, all these things. So this is the passive margin, and within the craton itself some rift basins are there which are called olacogen. Olacogen are the failed rift systems. So in essence, there are six types of major sedimentary basins in our geological plate tectonic settings. So from trench to olacogen. So these basins are responsible for getting sediments with the hydrocarbon sources, and then we should analyze that which basin are very much important for the hydrocarbon source. So these are the six main basins. Now, what just see that the what how the basin will be subsiding. We know that in our large lake system, or in our this the that your open end, your this passive margin system, what happened? Sediment loading is a very important phenomenon. In we have seen that when sediment is coming and it is accumulating on a depression, slowly and slowly the depression, the sagging part is being increased, and more load of sediments are coming, and it will be deposited or accumulated on the basin, in the basin, and the basin is being enlarged in itself. So first a small subsidence, and if it is a lake or sea, whatever it may be, this is called the distal proximal part of the sea or your large lake, and this is the distal part. Now, when sedimentary outbuilding is going on, then a regression is taking place, and number one, it is marked over here, a small subsidence is there. Then again, over one, another number two, this sedimentary strata is being deposited, and again the regression is going on. So slowly and slowly, the your oceanic part or your lagoonal part, that means your water part, will be diminished, and the total area is covered by your 1, 2, 3, 4, like this, some sedimentary horizons. So accumulation of thick, shallow marine or alluvial plain sediments are doing like this. So this is the normal way of subsidence, and how when the sediments are coming, there should be adjustment between the your loading of the sediment and the spreading out of the sediment. That means load both horizontal and your lateral widening will be going hand in hand. So that is the normal way of building of a normal sedimentary basin due to loading of sediment. Now, going to the next one, you know that the rift. What is a rift? Rift is it is well within your continent and within your ocean also. Mid-ocean rift, and in continent also. The rift is a situation where we are getting a basin, a depression called rift basin. So down-dropped basin due to rifting, that means due to faulting. Faulting is coming here because the continental crust is being stretched in both ways. How it is being stretched? Before now there is a just keep it in mind that we are getting a thinning and stretching out of a continental crust. But before that, there must be some overloading in this particular area, and over thickened crust must be there. If it is not over thickened, you will be very sure that it will not getting thin, because we know the adjustment theory, that when it will be more over thickened, that is the place where your stretching will be done both way from the over thickened part. So before rifting, you must have an over thickened crust. That is the way that we have in our every suture zone. That is there is a big suture zone, that is your CITZ is there, or CISZ, and with that your western part of your this western margin of your Eastern Ghat mobile well, it has a number of contact with the cratons, Basar craton, Dharwar craton, everything is there, and that means that suture has been developed due to thrusting of this of your eastern Ghat towards west, overriding, and then a very thickened crust over the craters. So these are the zones which we are actually called the suture zones. And these suture zones were these two continental crusts juxtaposed, and they are over thickened. Just after some time, that means a geological time scale, there should be again a rifting or thinning out along that suture zones. So those suture zones are again getting thinned, and when it will be thinning, that your trans tension will be there, and your rift valley will be formed thereon. So this is nothing but the part of the Wilsonian cycle. We know that closing and building of ocean or like that. So this is now we are seeing a rift valley in this diagram. So what I want to mean, that before this rift valley, you should get a over thickened crust over there. So after some geological time scale, again due to this plate tectonic, this theory, so this is tension will be there, and you will get this rift valley. Now how this rift valley will be formed? Obviously, the crust will be thinned. If it will be thin, then what should be there? Then your asthenosphere below this your continental crust, that will come up. And if it will come up, just you see that a bulging of asthenosphere, this green shaded part is the your asthenosphere. If it is like that, it is move up just at the central part of this deep valley. If it is moved up, then there is a thermal perturbation. What is thermal perturbation? Because earlier, if it was 600 degree centigrade, 700 degree centigrade, 800 degree centigrade, contour lines are there, then if your asthenosphere will come up, the hot molten state will come up, and you will get 900 or 10,000 degree centigrade temperature. Normally, where we expect 700 to 600 degree centigrade, then the crust will be heated, that will be melt, and in that way, your this lavas are coming out, and you will get this arcs. So arcs will be there. This in your island duct type also, in the subduction zone, and in the intracratonic rib valley also. So in the rib valley, no, when it will be in that state, that is so much rifted, you will get some volcanic or some your intermediate rocks over there, and those rocks are the result of the partial melting that Rift Valley position. So that is the essence of the Rift Valley, and we are getting here. You can see that large and large your basin, and basin is widening up two ways, and it is the mid portion. It is the deepest part will be in the mid part. So reef basin is another important part of a basin. Next one. So this is a the strike slip or range basins, or it is also called the pull apart basin. You can see the diagram that if one block, if one continental block, if there is a suture zone or a shear zone or a bend like shear zone, that should be bend. Just you see here that a bend over is here. So if it is a bend in a shear zone, and if the two parts in the opposite side of the shear zone that will pass to one another, then what happened that here just you see that where I am okay, adaptation there, yes, this part I am telling about this part. So here, what happened? This is a right lateral right stepping fault, or a bend, transtensional bend of a shear joint. Here, the northern part is moving towards your right, and the lower part, southern part, moving towards your left. Then what happened? Then a basin will be formed when it will turn apart, and this basin is actually called the strike slip basin or pull apart basin, same like this. This is almost a rhomb shaped basin everywhere. The normal situation is rhomb shaped. It is also called, as is due to the strike slip movement, it is also called strike slip basin. So this is also a part of the basin, and it will be formed in the right in the intracontinental part. So within the continent, if there is a huge shear zone or a fault zone that is bending, that is right lateral right stepping or left lateral left stepping, then when the slight past of the two blocks will be there, when movement will be there, then slowly and slowly the basin will be formed in the midway at the bend of the transtensional parts, and this is called the pull apart or your side slip basins. So now next, this is the passive margin. You know this thing, just I am reconciling these things. Just you see that is Rift Valley, basalt flow, mid-oceanic reef is there, and it is not the oceanic part, it is the continental part. So it is the continental crust. Now it is being rifted, and the basin is being formed, and at a some geological time scale apart, what happened that a large area has been taken up by this. This is the Atlantic Ocean. I am seeing. I am showing here. The western part is the east coast of North America. It is the west coast of Africa. So actually, it is the torn apart of a continental crust, and then the basalt flow is coming out. This is the Rift Valley. This is actually the passive margin. It is not the active margin. Active margin means where your subduction is going on. So that is the active and this is passive margin. Now stages of active margin, this is the subduction. Just I told you, accretionary waves are there. You know all these things I know. So volcanic arc is going on. So just you see that in that depression, when the subduction is going on, it is the continental oceanic crust is going beyond your continental crust. A depression is there. It is called the oceanic trench. After that, volcanic arc. Volcanic arc beyond before volcanic arc, this is fore arc. After volcanic arc, this is back arc, and now if it is the continental crust, so back arc spreading center are there. So the essential is a back arc basin, fore arc basin, oceanic trench. So with the active margin subduction zone, these basins are very common. So back arc, fore arc, and your oceanic trench. So when back arc will be extending, so this is actually the open ocean it is going on. So I am not going to that part. So it is just separated here from. It is just separated here. I have just separated here from here because this is the part of the active. So I think you get it. So this is the normal situation. Now conversion of a passive margin to a convergent margin. All these things are very important because we are describing basins, and basins are a part of either a active or a passive margin or the interior of the basin. In a continent, interior part, we know the intracontinental Rift Valley system we just discussed. Now, just use with comparing with this diagram, what you can tell that passive margin, when subduction is going on, again subduction, then in the right side there is a you know, yes, here it is a continental crust. A continental crust is moving, overriding with this subduction zone. It is coming again. It is colliding. As with the colliding, we know that Indian plate is subducting subducting beneath your Eurasian plate over there, and Himalayan mountains are going up. So just a few slides back, I told you that if it is going on, then there should be a suture zone. So this is the suture zone, and just you see the overthickened crust over here. So this is the overthickened crust. After some time, this overthickened crust must be rifted in the intracontinental part, and you will get a Rift Valley system there. So this is one, and in the when this is what is this? The passive margin to a convergent margin. So it is a passive margin. So passive margin now it is when it is collided with this, now it has become the convergent margin because the things have been convergent. Now with this, what happened? Now this part has been eroded out. When it is eroded out, we will get this type of things over there. So originally it was passive. We are seeing now it is a passive, but meanwhile, when plate tectonics theory and plate tectonics is going on, so it may be accumulated as a active and then again passive. Why I am telling it? Because when I am seeing a basin, I have seen the end part. What I am seeing that all these the sediments are accumulating and accumulating, and we know that from the very basic, from the very base of the sediment, when we are coming up stratigraphically up position, we will get different types of sediments and different at different edges, and we know that they represent different geological phenomena or geological activities. Those are, or tectonic activities. Those have went those days in those geological scale days. So what happened that we are getting sediments. That sediment is a reflection of the age of a particular stratum with that the reflection of the tectonic activity, what happened at that particular time scale, and again the phenomena that it is what is very important in our perspective, that whether it is a Proterozoic, whether it is Archean, whether it is Paleoproterozoic, or whether it is a late Proterozoic, whether it is Paleozoic, or whether it is Neozoic. If it is like that, that different biota or different types of organisms are coming from the Proterozoic to your these recent times or Neogen times, and we are getting different stratum, and we will get different connotation for that. And this is the essence that okay, we are getting a particular that is association in any stratigraphic column like this, the second one B, and we are getting this molasses type, this sediment, this your continental type, and with this some oceanic sediment, and with this some this just what I can tell you, that the tectonic sealed area, that is the where no tectonic activity is going on, that is your cratonic sealed area. So if in a sedimentary basin we are seeing that a
कौन पढ़ा रहा है? सुदीप भट्टाचार्य से।
tectonic sealed or tectonic this
ये
this
कोई देख के तो नहीं लग रहा है, देख के तो नॉर्थ ईस्ट जैसे लग रहा है।
and if any question please. Hello.
चलो फिर आज 11 भी बज गया।
हाँ, हेलो
सब्जी बब्जी
देवाली,
इतना मुश्किल एक तो
Any
अच्छा
question? Someone is asking anything? I don't know. So should I continue? Hello.
yes sir, yes sir.
Okay. So I want to see these things because in a stratigraphic column, we may get sediments coming from a passive margin, we may get sediment coming from an active margin, and ultimately we may see that the sedimentary basin is from passive, but constituents or elements of the active margin, if it is there, we should consider that it is going through a geological cycle, a tectonic cycle, that this is particularly not a passive. Earlier it was an active also. So that is the main thing for this. Now, passive margin is a detailed cross section. You know this. I am not going to that detail. Just you see the diagram. You can reconcile yourself that in the passive margin we are getting a number of faults. All these faults are more or less a district type of faults, and we are getting some fault bounded, just host and graben, host and graben like this, and almost the rolling. It is the rolling faults are there. So one thing is very clear from there. Just you see that the different types of sediments are being accumulated. I have marked it. There is a rock salt. It is Jurassic salt, Jurassic type, and below this is a Triassic deep valley sediments over there. So Triassic deep valley sediments, Jurassic deep valley sediments, Jurassic salt, and they the Cenozoic sediments over there. So in a passive margin, we may get a huge sedimentary thickness, and with that an information of from almost Jurassic or Triassic up to the Cenozoic. So a wealth of information we may get, and these are very much important for our this hydrocarbon generation part, because we know that this reef system was there, our foraminifer system were there. So everything those fossils, those plant remains from the nearby continental crust, or the your planktonic foraminifers, or those the sea marginal, this your biota. All these things may be accumulated over these areas only, and this is a prolific. There may be prolific potentiality for the your hydrocarbon potentiality of these passive margin areas. So this is very much important in that respect. And the next one is a foreland basin. Already I discussed it, but just you see this, that the foreland is nothing but we are seeing that the sediment filled plain south of the Himalayas, just south of the Himalayas. This is just you see that there is overthickened crust over here. Here the subduction zone. It is your this Himalayan terrain maybe, and just foreland south of that we are getting some plain land. That is in the south. It is filled up your this these sediments. So here the sediments are coming from the continental part also, and also from the this volcanogenic part also. So a mixed sediment should be there, and this is very important as because this here also we are getting the deep your deep water sediments and the tectonic sediments, and with that the your this inland flora or inland fauna. So this is a mixed up zone. So foreland basin is also very important from the part of your this hydrocarbon potentiality component. Now, so these are the essential basins. We discussed these things. At this juncture, I want to tell that if any question is there, they may ask or they may ask afterwards. It is up to you. And these are the 6 total basins that may be grouped. So after all these things, what we are going to do? We are going to find out that, okay, then in our India, what types of basins are there, how many basins are there, and how they can be clubbed or grouped into different types of these basin types. So in a review paper was there, and it has shown that altogether there are almost the large, small, minor, all these sedimentary basins constituting almost 38 sedimentary basins are there in Indian continent, subcontinent. And all these 38 sedimentary basins may be grouped into 4 main tectonic settings as we have discussed right now. So within these 4 main tectonic settings, the first one you can see the intratectonic sag basins. Sag basins means the primordial, your primary depression. Some depression is there and sediments are being accumulated, not related with the active, tectonically active basins. So this is the intratectonic sag basins. And in most of the times, the sag basins are being affected by the basement faults, and then it is being transformed into the deep basins. So some sag basins, that is the old basins are there, which are not being affected by these types of basement faults. So they are remaining over there. These are called the sag basins. So intratectonic sag basins, then intratectonic rifted basins, obviously you know these things, then perictectonic basins, and orogenic or foreland basins. Orogenic or foreland basins, just I have described the foothills of Himalaya in the northern part of India, and in the Assam, Arakan part there in the northeastern part. So those are the orogenic belts and orogenic foreland basins are there. And the third one is the perictectonic basin. Perictectonic means that those basins are around our Indian subtectonic domain. That means it is within the seawater. That is under the mean sea level, and it is just around our your in the peripheral part of our subcontinent India, to the eastern side of our continental margin and to the western side of our continental margin. So these are the main four tectonic or main four geological settings or sedimentary basins, where all the 38 sedimentary basins, hitherto that is numbered like this 38, it may be 39 or 40. If someone may tell that yes, I have described an 1 square kilometer basin over there, so that is not included over here. It is the major basins or minor basins which are all at least 5 square kilometer its area span. So this is the 38 sedimentary basins all over India, and they have been clubbed together. Within this 38 sedimentary basins, as you have seen the next point, that 23 sedimentary basins based on the hydrocarbon productivity, it is very much important. So hydrocarbon potentiality or proclivity is the, we can find within the 23 sedimentary basins out of these 38 sedimentary basins. So can you get it that the other 15 sedimentary basins are not potential in the perspective, from the perspective of the hydrocarbon prospect. So your 23 sedimentary basins covering an area of almost 3.14 million square kilometer, including the deep water area beyond 400 meter bathymetric. So these 23 sedimentary basins are our this our objective should be there for the hydrocarbon prospecting. Others are not that much important. So up to this, I think it is clear, because now it is very clear that within these 23 sedimentary basins, which are productive in respect of your hydrocarbon prospective, so within these, the main or text settings are coming, the main types are coming, the intracratonic rifted basin number 2, pericratonic basin number 3, and orogenic foldland basin number 4. Intracratonic sag basins, those are not so much important, and they are categorized afterwards. I will tell you, because during the constant increasing demand, it is also now, they are also now under the surveillance, and we are taking account of them, that what are the sediments over there, and can it may be transformed into any energy purpose. So that is the main thing. So up to this, I think it is clear. Now the intracratonic basins are, I need not elaborate it, that these basins are your Gondwana basins with the host and graben structures, structural depression of sag basins as Vindhyan, Kadapa, Kaladgi, and Bhima. Just that these sag basins, I told you earlier that the sag basins, as Vindhyan, Kadapa, Kaladgi, and Bhima, they are not that much important like this your reef basins. So this is very important, that sag basins are having the proterozoic sediments. Proterozoic sediments are not that much or biota rich in that time, and that's why this is the cause that why they are not that much important. But we know that carbonate sediments are there in the Vindhyan, Kadapa, Kaladgi, and Bhima, and with this we are having also some cell-rich part over there, black cell-rich part. So those are the large lagunal or large lake deposits. So possibilities are there to find out if there is any such possibility is there, that those that hydrocarbons may be extracted from that basins. But the mains are the Gondwana basins, gravens, and they are for your this solid fossil fuel or your coal or lignite. Now, most of the Indian sedimentary basins are very cratonic. I just told you that Indian plate radially, bordering the Indian plate radially, and beyond that, we are having the four land basins, Assam, Arakan, and Himalaya. That is the orogenic belt. The coastal pericratonic basins, especially in the south, are extending from offshore. I told you onshore to offshore, and a reef-fed basin separated by host. This is very much important and particularly important in our perspective that peritectonic basins, our main source of petroliferous basins, are there, and we are getting the different. Now, you can tell me that these peritectonic basins are should be what type of basins? They are bordering the onshore to offshore, the Indian plate. That means they are the what I told you earlier, it is the this type of just let me tell you one thing. This type of thing, that is a passive margin. They are the these things. They, they are the these things. Passive margin. We are delineating a part over here. So this is the area of pericratonic part where we are doing our all this hydrocarbon potentiality, offshore hydrocarbon potentiality we are finding out. So this is very much important, and it is these things maybe happen after this active, or initially it may be passive. After that it is active, and then it is passive. Now we are seeing it is as a passive. So that is very important, that what I am telling you now, that these offshore to onshore, these coastal pericratonic basins are, most of them are the passive margin. And if it is a passive margin, they have the signatures of their own structural culminations. Those structural elements preserved over there tells us that yes, what is the actual cause of forming these basins, or what are the sediments that has been accumulated up there, that why they are rich in hydrocarbon, or they are rich in hydrocarbon actually or not. So these things are very much important for the next part of the discussion. So, Proterozoic basins, you know the sag basins, and you know the architecture of the Indian continental part. So, the cratons are there. This is the CITZ. I know you. I told you earlier. Mohanodi Reef, Godavari Reef, CITZ, and this is the CITZ over there to the Assam Arakan, and then again it is coming like this, and it is the Eastern Ghat mobile whale. So here it is your Kadapa. I have shown it here in a larger map. So these areas, the Chhattisgarh, Kadapa, Vindhyan. So these are your Proterozoic basins, Kaladgi, Bhima basins. So some cratons are there. Within the cratons, the sag basins are there. So they are not controlled within the craton. They are not controlled by any such tectonic element. So these are the basins which are called the sag basins, and I will discuss this later because it has not so much of that your hydrocarbon potentiality. Some are coming right now. So in the present days, some papers are also coming that yes, hydrocarbon potentiality is there in the Kadapa, in the Vindhyan, and we can extrapolate something from there regarding your hydrocarbon potentiality. That is later. So proterozoic basins. Now coming to this part. So up to this, your basins are over, and we will after that we will go to the solid fossil fuel and the basins where it is occurring over India, and then to the liquid fossil fuel where it is there in India, and after that some gaseous state. In the solid is over, liquid is over, then the gas. Gas means that is the some hydrocarbon potentiality, which is the future of not only India, the total world obviously. That is your coal bed methane and shale gas, all should be there. So there is the gaseous part, and then at the last part, I will take up the hydrates, that means the gas hydrates. That is also a source of energy, that recent times we are thinking of to get the energy from there. So up to this, the basin, that is the type of the basin, what are the basins in India, it is over. Now we are going slowly by slowly. Now we will enter into the solid fossil fuel part or coal and lignite. So it is over. It is over. I am requesting you, just if you give me just 5 minutes, is it possible?
Yes,
Uh,
yes, sir. Yes, sir. You, we also want that you should take rest, sir.
and in the
Yes.
meantime, if any question is
If
there,
you,
please,
yes,
please.
if you have any question, then you can write on the chat box whatever till now it has been covered. All are requested to put the question on the chat box so that sir can answer. Okay, so I think 10 minutes, sir.
Another thing, they can also
Yes.
ask me, no problem. Just give me 2 3 minutes. I will take some my medicine and then again I will return. No problem.
Okay.
So just they can also ask me. It is better to discuss. ये लिखने से ज्यादा कुछ नहीं होता है, डिस्कस करने से ठीक है.
Okay. Okay.
उसमें मेरा प्रॉब्लम नहीं है. Just give me 2 to 5 minutes. Okay.
Okay. All are requested to stay here. So it will continue after 2 3 or 5 minutes.
Because just after this we will go to this coal and this hydrocarbon part. What are the hydrocarbons? That part. Basin is over. Now hydrocarbons. Now how the hydrocarbons are occurring in solid and liquid hydrocarbons are occurring in our Indian continental part, and with that some gas and gas hydrates. So this is the main objective of my this deliberation. So please look for those, and if any question, please ask me. Just give me 5 minutes. Sorry. In the sandstone, we are not getting that much of organic matter. So that is the cause. Those basins which are normally fed by this your very sediment sandstone laden or that is the sand laden water. So that is the only cause for the not getting that much of hydrocarbon over there. There may be some shale, but not that much. That is not potential for that. But where in the other 25, other 26 sedimentary basins, 26, other 23, sorry, 23 sedimentary basins, we are getting that sandstone is there, but with these, the argillaceous part, that is the shale part is also very much. So these are the exact areas, the basins where we can get it. And this is obviously according to your this what that is we call the source rock, that the source rock is like that your these sediments are coming from those areas which are nearby areas. Those are giving you this sediment, that is the sandstones, that is the sands, or that your arenaceous part of the sedimentary cycle. So that is the only cause for that. So clear it? Clear? Hello? Hello?
Hello. Hello.
Is
Yes, sir.
is
Yes, sir. Yes,
is
sir.
is it is it so it is actually depending on provenance. So from what provenance your sediments are coming? Okay. So
Okay, sir. Okay, sir. Thank you,
okay.
sir.
Any question, or should I go to the next one?
Hello, hello, sir.
Yeah, yeah.
I am Kapil Saloko from Wadia Institute of Himalayan Geology, and I
Okay.
work in the Indo-Burma range. And Indo-Burma range is known to be deposited by an accretionary wedge. So,
Yeah, yeah.
can you kindly elaborate a bit on the mechanism of accretionary wedge?
Accretionary wedge. Huh?
Yeah.
Yeah. So accretionary wedge, that is called the accretionary prism, at least. Oh, yeah. So that is
Yeah.
called accretionary prism. So I am giving the again I have returned back to that active margin development diagram. Just you see that accretionary wedge is there. Are you seeing that? Are you seeing that
Yes,
accretionary
sir.
wedge?
I'm seeing it.
Yeah. So where an oceanic crust is downgoing and downgoing below a overriding continental crust, then what happened? Then your these on the back of the oceanic crust, the sediments, those have been deposited over there, they are getting thrusted. Why thrusted? Because or constantly this area, constantly pressure is coming from this side, and this side is almost static. So this side is static, it is not moving, it is moving. Then the sediment wedges or sediments within this domain, it will be stacked up, and it will be coming with some folded horizons within this domain. It is actually called the accretionary wedge, because the sediments which are accumulated over there, they are both pelagic sediments, and they are also called the molasses deposit, because it is, or fleece species, you can also tell it, because that is the that your this chart is also there, radiolarian chart will be there, your this your magmatic rocks will be there, and with this the sedimentary marine sedimentary rocks are also there. So all are mixed up, and all are giving you the folded sequence, which ultimately, due to this thrusted pressure, under thrusting pressure, it will come up as a wedge shaped and a folded horizon. This is actually the within the Burma and this our Indian plate. See, Burma is this whole land. These areas are covered up by this accretionary wedges. The same thing we are getting there in the Andaman, and there Andaman accretionary wedges. So these are the areas where the sediments which were being deposited are being thrusted. Why thrusted? Due to the unidirectional pressure of this under thrusting crust and the static part of this continental crust, the wedges of these sediments are thrusted out, and they are arranged like some folds over there. This is actually we are getting that is the Assam Arakan fold whale, or the Burmese fold whale we normally call it. So is it clear, madam?
Yes, sir. Sir, then this accretionary wedge of prison, it is resting on the subducting plate or on the Burmese plate, like the Indian plate is subducting. So
Yeah,
where it is resting?
yeah. It is on which it is resting. It is the downgoing plate. That is the Indian plate. Okay, that is the
Okay.
Indian plate is downgoing. Always it should be like that. Now, which one is downgoing? That is the down thrusting. So over that the sediments will be deposited, and you are saying that this is a position where we are getting in the oceanic trench. Everything should be mixed up. Your island arc sediments, your oceanic pelagic sediments, your this some your magmatic rocks also will be there, because it is coming from a very great depth due to the accretionary thrusting, and we are normally partial melting, high pressure and the high vapor partial melting is there, zone of fractional melting is there, and we are getting so much. This is called the Steinman's Trinity. That is the three things are there. That is your pelagic, all are there. So that's why it is the accretionary prism. Got it, madam?
Yes, sir. Thank you, sir.
Okay. So should I go? The next one?
Yes, sir.
Okay. So now we are entering the different types of hydrocarbons. Not going to that detail because it is not. We only deliberate that what are the types, how can a basin, and we are in which basin we should get a coal, or in which basin we should get a petroleum, like this. Though we are, I am from your solid fossil fuel, and GSI, obviously GSI is not dealing with the liquid fossil fuel, that is the petroleum. But as it is a hydrocarbon here, we should not avoid that petroleum. We should take some things from the when this is research work, or when this is things that what they are doing, that is regarding this oil and natural gas. So before going to that, so from the solid we are just starting. So coal is a major source of energy, and it is the most important part is that a very small part of carbon cycle is a dynamic carbon, and it is being entrapped within this peat, lignite, coal, petroleum and natural gas as a part of the fossil fuel, solid or liquid. So if it is a coal, it is a hydrogen deficient, definitely an aromatic compounds. If it is oil and natural gas, it is hydrogen rich aliphatic compounds. So these are the main. There is a coal and lignite. So coal and lignite, before going to any type of this hydrocarbon, the mother of the hydrocarbon, what we are saying everywhere, whether a hydrocarbon will be solid, it will give you coal or lignite, or whether it will give you gas, or whether it will give you petroleum and natural gas, like that. It all depends on the source or mother of this hydrocarbon, which is called kerosene. So kerosene is the source of hydrocarbon. It is very important that to recognize, or to determine that which type of kerosene we are dealing with. If we are dealing with different types of kerosenes, then it will give you different types of the of your product. If the kerosene is derived from the petroleum, from the your aquatic source, most probably that will give you the oil, and if it will from terrestrial, it will give you the gas or some oil. And with this, the main thing is your coal and lignite. So what happened? What is a kerosene? Kerosene is that it is a naturally occurring solid insoluble organic matter. It is written over here, just you read it out, that occurs in the source rocks and can yield oil upon heating. So it is a naturally occurring solid insoluble water. Kerosene is the portion of the naturally organic matter that I am giving you just one thing, that kerosene have a high molecular weight relative to bitumen. Okay. Apart from this, what is a kerosene? Kerosene is that part of a hydrocarbon. Just you take some cell, and after taking that, it will be treated through some chemical reagents at laboratory. What happened? We will treat it with a very high concentration of hydrochloric, nitric, and sulfuric acid. All these very high strength active acids, we will treat those cell samples. If after treating that, if all the samples will be exhausted or or have gone to the dissolution, you will have that no kerosene is there. But if after giving so much treatment with the strong acids, if some insoluble part will be there that cannot be taken into solution with this high strength of acids also, then that part is called the kerosene, and it is actually the kerosene which we want to know that if it is aquatic or what it is type. Now, according to the variety, the kerogens are of four types. Number one, two, three, and four. So these four types of kerogens are there, and these kerogens. अच्छा ठीक these kerogens are now it is there the number just a minute. Number 1, 2, 3 and 4. So four types of kerogens, and you are seeing here that their origins are different and different. According to the origins, the hydrocarbon potentiality is also different and different. Now, some terms are here: alginite, amorphous, exenite, vitrinite, inertinite. I will discuss a brief of this just to reconcile yourself. And, and the origins are there. There is a line over here. Over this is the marine origin or aquatic origin. Below this is the terrestrial origin, aquatic and terrestrial. So the results are different and different. Next, the types of kerogen. Just you see how to plot it. Now we have got that insoluble part. We tested it at laboratory. We will do it the pyrolysis, and we will get the ultimate analysis also. Oxygen, carbon, hydrogen, all these things will come out. This elemental analysis will come out from there. So if that will come out, and we will plot like this, that at the x-axis O by C, oxygen by carbon ratio, and the y-axis H by C. The next diagram is also like that, O by C, H by C. We are getting this distribution of these different types of kerogens over there. This is type 1, very high H by C ratio and very low O by C ratio. Type 2, somewhat less H by C and medium type of O by C. Type 3, it is the H by C is medium and O by C is high, and type 4, that is the H by C is minimum over there. So four types of kerogens. This is coming from algal part. It is oil flow. That means if any hydrocarbon is there, we analyze this as a type 1. We will be very sure that that kerogen will be oil prone, and that basin from where it has been taken out, the rock from where it has been taken out is an oil prone. So go for searching for oil for that. If it is a type 2, it is some hydrogen rich and oxygen poor. It is also oil prone, and some hydrogen rich part is there. Some gas is also coming over there. So it is totally oil. It is oil and gas. Here in type 3, sir, it is type 3. It is from the land part. So it is absolutely about your solid fossil fuel. So it is coal and lignite like that. With that, some gaseous between the type 2 and type 3, some areas are there. Gas. And type 4, it is total the carbonized material. So it is, you are not getting any oil and gas from there. So it is totally aromatic carbonized material. Here we have plotted some coal seam analysis from some coal seam over this. So just you see that here all the coals are plotted like this, and some coals are bituminous, some coals are lignite. When some coals are lignite and bituminous or subbituminous, and it is humic peat. When it is going over that here it is some huminite, vitrinite. I am coming later, inertinite, whatever it may be. The bituminous coal and our normal coal and lignite will be over here. And just you see our some coals, if it will be reaching sporinite, cutinite, it will be straddling over this type 2 also. So they are very rich for oil prone also. So it is alginite and this is totally oil. So this is the area of the different types of kerogens, and directly from any source of hydrocarbon we can analyze and we can plot it and we can determine that which type of hydrocarbon potentiality we are searching for from that particular basin. Now, petroleum source rock. Now, I have told you that petroleum is also a part of it. So, petroleum source rock means it is an organic rich rock. Organic rich rock, and now organic rich means whether there are organisms associated, whether there are organisms associated with the sediments, and those organisms are enough for giving organic richness to that particular rock, and what is their thermal maturity. A very important term is coming over here: thermal maturity. A hydrocarbon rich source may be a hydrocarbon rich source, but you may not give you the generation of coal or lignite or oil or gas if that is not that much of maturity is there. That means the hydrocarbons should have been cooked enough in the terms of cooking. It should be cooked enough to give you that particular phase of maturity by which you can get an oil, gas, or a solid fossil fuel. So this is very much important. So thermal maturity is an important term, and these are very important correlation terms are there. That is, thermal maturity is there, but if organic richness is not there, then it is not also viable. And if organic richness is there, thermal maturity is not there, that is also not viable. So those things should go hand in hand and simultaneously to give a very good reservoir of either coal or shale or gas or your oil, like that. So this is the main essence of the hydrocarbon potentiality, and kerogen type 1. That means up to this we can tell that type 1 to type 4 kerogen we have got. We know that which type of kerogen will give which type of product, and with this we want to know that what are the actual organic richness of that particular sediment, organic rich sediment, and what is the thermal maturity. So these things are coming one after another. So petroleum generating potential, just that's these questions. You are also having these questions in your mind. I have just jotted it down here that first, does the rock have sufficient organic matter? The question has to be answered first. Second, is the organic matter capable of generating petroleum? If so, is it oil prone or gas prone? For petroleum, that means it is from the liquid fossil fuel. And again, we can tell here that whether this organic matter is capable of generating coal. We are not discussing this here because if there is coal, we are seeing coal. We can look it in the stratigraphic color. So it is there. So that's why there is no, it should not be recorded here. So if it is coal there, we know, yes, the hydrocarbon kerogen, generating kerogen should be of type 3. So that is like that. Third, is the organic matter is thermally mature. Fourth, have generated hydrocarbons been expelled from the rock? That is also one of the very important question. If it is there in situ, if it is there in the ambient, or it has gone there from the reservoir side to another side. So these are some questions. The maturation of hydrocarbon, thermal maturation, I was telling you, during the phase of catagenesis, kerogen matures and gives off oil and gas. What is catagenesis? Catagenesis is coming right below your diagenesis. There are three maturation indexes are there. That is according to your pressure temperature. What happened? Any sediment will go must have gone through this part. That is, the first part is your diagenesis, then your catagenesis, and then your metagenesis. Metagenesis is nothing but the metamorphosis, or the metamorphic regime has come after the catagenesis part. So during the phase of catagenesis, your kerogen matures and gives off oil and gas. Establishing the level of maturation of kerogen subject to, now we know that thermal maturity is the answer for this. When kerogen is immature, no petroleum has been generated. With increasing maturity, first oil and then gas are expelled. So first window is your oil window, and then will be your gas window. I am coming. When kerogen is over mature, neither oil nor gas. So the kerogen must have been cooked very, very critically. Otherwise, it may be less cooked, it may be overcooked. If it will be overcooked, you will not get oil or gas, or you may get some gas from there, not oil. And if it is less mature, you will not get anything. So, there is the maturity is very much important. So, before up to this, it is like that, and we know afterwards, we know how we will determine the maturity of this, thermal maturity of this kerogen. It is very important, and I will discuss something on it afterwards. So up to this, the kerogen part is what, that is the mother or source of hydrocarbon. Each type of hydrocarbon, it is there: type 1, type 2, type 3, and type 4. Up to this, it is okay. Any question, please ask me. Then I will switch over to the solid fossil fuel, how it is formed, and what is the very brief, very brief. So up to this, any question, please? Hello.
If you have any doubt or any question till now, you can ask.
Or you can ask afterwards also, after completing these things, no problem. Just I am clarifying that whether there is any problem up to this or not. There should not be, because we know pinpointedly that which type of kerogen is giving which type of product, that is solid or liquid fossil fuel or gaseous fossil fuel, like that. So this is very much important. So okay, I am going to the next one. Next one is I am not going to any detail. This is the coal forming environment. All the things are written over here. I am not going to use those. Just you see the diagram. Two diagrams are giving here. One is a warm, humid climate, luxuriant growth of vegetation, and another is your river and channel, interchannel system, or river, your overbank system. Just you see that is the river in between, and the overbank deposits were there, and it is full of your this vegetations, low vegetations, and long vegetations, tall vegetations like this. And what happened? There is a breaching over here. This is actually the natural levee. Breaching the natural levee, the sediment-laden water during a high tide or high flow, it is high flood. It is going beyond this natural levee, and it is engulfing the cover, making a cover, or a blanket over the this this overbank deposit. Now what happened in this overbank deposit? All these vegetations will go under the this sandstone laden water, and in a geological time scale, that will be solidified. What happened? We will get a sandstone above, and after below that, we will get that plant rich, that is your coal. And in the overbank deposit, we are getting this channel, interchannel deposits. We are getting this coal seams, and below these coal seams, with these coal seams, the cells are also there, and the sandstones are also there. Yeah. So normally, if any sandstone, it is called the crevaceous clay deposit. If it is giving a blanket over there on the vegetation in the interchannel deposit, then we are normally getting coal, because coal will be formed as your plant materials will not come in an oxidized state, and it is covered up by the blanket of the sandstone going under the water table. So that is a very common that is a common area where we will expect geologically we will expect the coal will be there. So ecological condition, high luxuriant coal, a suitable climate favoring high luxuriant coal, peat forming plant suitable condition should prevail, and a suitable depositional environment should be there, like this interchannel deposit, and the basin should be there, which should accommodate all these shale, coal, and sandstone, a slowly subsiding basin, obviously. And with this, the EH is also very important. That is your condition of your groundwater, whether it is acidic, whether it is basic, alkaline, or whether the oxygen supply is much more or less. If oxygen supply is much more, then coal will not be formed because aerobic bacteria will be there, and it will be out of your groundwater table, and it will be perished, it will be demolished. No plant material will be decomposed to give you the organic, that is your hydrocarbon source, that is the type 3. Now we can call it the type 3 kerogen is not being formed if it is under the high oxygen flow or high oxygen supply. So these are the things that are very important. With this, the tectonism. Tectonism, if it is a lower rate, that is the rate at which plant is, that is the rate of subsidence of the basin. That basin should be subsidizing at an optimum rate, not very fast and not very slow, just to accommodate your sediments. Just now you can recall the first or second slide I have shown you, that 1, 2, 3, 4, all the horizons. Can you? I am not going to that diagram. Just I am telling, possibly you can recall that diagram. That 1, 2, 3, 4, those things are, those lithological units are being deposited, and your basin is widening, basin is subsiding. So that is the optimal rate the basin is subsiding. If any hydrocarbon source will be there in the form of type 3 kerogen, that is your coal will be accumulated there, then that will be preserved over there. So that is the very important thing for the coal part. Now just you see that the environment, we are talking about the basin. Different types of basin should be there. Is a large lake, lacustrine type deposit. It may be some deltaic, lagunal basin, and with the deltaic basin like this. So different types of basins are there, and the black this part, they are the coal seams. Just you see that the coal seams here, it is more straight, and it is following the regular behavior, and it is extending kilometers over kilometers along both strike and dip. So they are very much important sources of hydrocarbons. And here also we are getting the second diagram, that is in a deltaic diagram. It is deltaic, but not that much of delta. It is you can see that the lower seam there is almost continuous one, but in the upper seam there is splitting, and there are some sandstone here and there. I think you can see here, I think you can see here, but for this it is totally like this. So these are the things we are normally seeing in a coal bearing sedimentary basin, that some coals are extended along strike and dip, but some are not. They are splitting, again coalescing, again like this. So these things are coming. So if this is the case, then again another situation is there where we are getting digitized hydrocarbons, digitized coal. That is, it is the dissected, bisected. Just you see over here that some are there, but they are not their behavioral pattern are not like that. They are extending kilometer and kilometer. They are just digitized pattern and splitted pattern like this. So why? Because here we are getting in a lacustrine deposit. This is the distal part of a lake, and this is the proximal part of a lake, undisturbed and not much disturbed by your tectonic activity also. So the things are like this. This is the normal scenario of European coal. And there we are getting kilometers and kilometers of coal seam over an area. But it is not true for our case because ours are normally not that much of mega stream. Ours in India, it is normally of your deltaic and lagoonal environment. And normally we are getting this. Where we are getting this type of coal, again we can say that from the lower stratigraphic level, the coal, it will be a lake system operated that time. But when it is going up in the Younging direction or stratigraphically up, the upper coal seam, for the upper coal seam, we are getting not that much of regular framework. We are getting the digitized splitting like that. So in that sense, the deltaic environment has come up in the same basin in the stratigraphically upper sequence. So I think it is clear to you. And here, if in any situation we are getting no, not this is also not preserved, everything is like this haphazard and splitted, then we will go to that conclusion, yes, we are now very near to a seashore or like that, or we are getting the deltaic environment, and the digitized pattern is giving us the conclusion that it is in the upper or lower delta or the mid delta like this, and the total your this shell sandstone intercalation, the shell sandstone layers, that is your actually called your deltaic environment. In the deltaic environment, the high energy and low energy condition, they are prevailing very rhythmical, in a rhythmical behavior, and we are getting this type of code over there, if at all it is preserved. So this is very much important, and from the hydrocarbon point of view, it is very much important, the upper one, and all these are important, but it is in our country, we are not getting like the European coal. And here lies the difference between the southern Gondwana coal and the Laudasian coal. Laudasian coal are like that. They are really very much, very extensive. Now, some terms you have seen there, that is the vitrinite, inertinite, and exenite. I am giving you one example, that when coal is observed under microscope, we are getting three types of components. These components, like minerals in rocks, it is macedals in coals. So in macedal means they are the organic constituents or micro constituents of coal, and after seeing the microscope, coal can be categorized in different manners, and we can tell that which coal it is, and what is the thermal maturity of that coal also. And here comes the terms thermal maturity, which we can provide, which we can also apply to the liquid hydrocarbon also, and to the gaseous hydrocarbon also. That means for your petroleum and natural gas. And just this thing we will apply there, and we will tell anyone that what is the thermal maturity of that, and we can tell that whether this sedimentary basin is well matured to give you petroleum or gas, or well matured to give you that different type of which type of coal. So this is the thing, that coal is a complex rock. It is that petrology is called organic and inorganic petrology both. It is actually coal is made up of your hydrocarbon, and it is HC, and HC is nothing but that is the aromatic rings are there, and we for this I am just see. I am not going to those details. Coal petrography, we are giving this. We are delineating these macedals, and that is the your indicator of coal type. Which type of coal is there? Macedal groups. Then the indicator of coal grade. What is the grade of the coal? How it is, and what is the rank of the coal? So all these things can be delineated from the different fundamental parameters of this coal petrographic study. So this is not the platform for this. I am not going to that detail. So, but just to for applying this in the hydrocarbon potentiality, which is very essential. That's why I am delineating this. So, vitrinite, lignite, inertinite and cell and mineral matter. These micro constituents are there. So Maceral, what is vitrinite, liptinite and inertinite, just summing up, this is one diagram. Just you can see a tree, it has been decomposed, it has been fell down, it has been decomposed, and what happened? After petrification, qualification, it will give the maceral. Now, what happened? All the tissues from your these main tissue cells of the stem, of the roots, everywhere. When it will be decomposed, that will give you vitrinites. When the your leaf, your spores, pollens, they will break down. They will give you the liptinite. Liptinite, the name suggests it is rich in lipid, that means fat. It is lipid rich, and when all these things, mainly liptinite, will what if it will catch fire when it will above your groundwater table, and it will be decomposed by fungus, and ultimately it will give you the inertinite. It is inertinite, the name suggests it is inert. That means no chemical composition or molecular rearrangement will take place in inertinite. And inertinite and liptinite, it is rich in lipid, and vitrinite, it is the main thing, that is from the cell walls of plant tissues, these things are coming. So main thing is our vitrinite, and it has got a reflectance value. It is called vitrinite reflectance, and that is giving you the your rank determination of that coal. So not going to that detail. So this is the vitrinite. Just you see the diagrams. So this part is the vitrinite. Different names are there. So under the reflected light, we see this vitrinite and inertinite. Liptinite we cannot see because it will be dark. It can only be seen under the fluorescence light, UV fluorometry. Under UV fluorescence we can see it, the liptinite, as it is lipid or fat rich. So vitrinite, then just it is inertinite. It's the fungus affected woody tissues preserved. So they look like this. Just you can have a look. It is not the platform for that. And liptinite, just you see the color. Just you see this. They are fluorescent. They are just fluorescence under ultraviolet light. So under normal light, reflected light, they will dark. So spore, pollen, cutin, all these things will give you this lipids, liptinites. So and now just a minute. Now another thing is there, that is rank. So rank, that means your thermal maturity that we were discussing earlier. Thermal maturity, it can be determined from the vitrinite reflectance value. It is actually called RO, random reflectance value. So these things will give you that what maturity we are telling, and the rank of the coal depends on the maturity. This is a high rank coal having the high maturity value, low rank coal have the low maturity value. And relationship of the vitrinite reflectance with the volatile matter and the carbon content, all those are giving that with the increasing vitrinite reflectance, your volatile matter will be decreased and carbon content will be increased. That is, rank will be increased. This is a very important diagram. Just you see that here in the left side, this kerogen is there. If it is there, then just you see that it is the depth. Along the depth, how it is changing? The kerogen, it is changing that most oil will come at a depth of around 2.5. After that 2.5 kilometer depth, oil zones, that is, it is called actually the oil window. They are coming. When oil window is diminishing, your gas window, whether it will be wet or dry, it will be increasing. So the petroleum, for petroleum, this is the case. The oil window will come and then come the gas window along the depth. Temperature along the according to the your normal geothermal gradient, it is here. It is the color. Now it is the vitrinite reflectance. Vitrinite reflectance value, you can see the value 0.5 that we have measured from the vitrinites over there. So From coal, it can be determined from kerogens in the for the hydrocarbon potentiality of oil. They are also having these vitrinite. From there, we can study what is the reflectance value, and along the reflectance value, if there is any reflectance value we are getting from 0.5 to 1.5. So if it is 1, so we are very well sure that we are within the oil window zone, and we are within the catagenesis process, and it is the area where from where the hydrocarbon is of oil potential. So this is very important. But if it is like this, 2 or more than 2, then you will not expect much of oil. You will expect much of your gas. So this is the importance for this reflectance, vitrinite reflectance value, and it is giving you the thermal maturity. So earlier we have talked about the organic richness and thermal maturity. So organic richness we can get from different analysis that you can get from your rockable pyrolysis also. It is actually the total organic carbon it is giving you. So total organic carbon, total organic content, whatever it may be, we can get it from there through analysis. We can get the vitrinite reflectance from here, and we can get the indication that whether we will get oil or whether we will get gas. If it will be a gas, whether the gas is saturated with water or whether it is dry below that. So everything will come out if those things will be done. So in a very nutshell, and after that, so for oil it is like that. Now as we are discussing with coal, a coal-based methane is also an integral part of hydrocarbon now. You know, so coal-based methane, and after that shale gas. Those are the game changers in nowadays. So coal-based methane, it is a methane. Now just you see, it is very easy. Just you see the the left your table, and you can see that according to the coal rank, we know lignite, subbituminous, lignite, subbituminous, bituminous, semi-anthracite, anthracite, meta-anthracite. So we are going from the diagenesis, catagenesis to metagenesis state of a organic rich sediment which is enriched in, suppose, type 3 kerogen. The type 3 kerogen means ultimately it will give you a coal or lignite. We know it now. Now, if it will be a type 3 kerogen, and if your thermal maturity value is less than 0.4, you will get lignite from there. And after that, you can see that within the subbituminous, it is not coal now. Till now, it is not coal. Now, if it is processed, and if we are getting a value from 0.4 to 0.5, we can tell that yes, this hydrocarbon will give you a subbituminous coal afterwards. So when we are dealing with an hydrocarbon in the form of a shale or in an organic rich clay, we can tell also that after a geological time scale, after some million years, if that will be accumulated and that will be preserved like that, it can give you the source for your oil or gas or your coal. If it is coal, which type of coal, we can give you the indication. But now, if we are having a coal now, we are having a coal in my hand, and I analyze that this coal is having a value of 1. Then I directly go to the plot. I will give you that yes, this coal is rank is high volatile A rank, and it is a bituminous coal. If it is going beyond this 2% maturity level, then it will give you the semi-anthracite. That means thermal maturity means vitrinite reflectance. I am talking about the vitrinite reflectance. So this is the value we are getting, and just you see when hydrocarbon of type 3 kerogen, it is being decomposed, what is coming out? Methane gas will coming out from there. How? During the diagenetic and catagenetic process, all the cellulose, just See over here, cellulose after reaction will give you bituminous coal, and with this CH4, CO2, CO and H2O. That means carbon monoxide, carbon dioxide, water level, and with methane. Here also lignocellulose also, it is not cellulose, the composition is different. It is lignocellulose. Now the lignin part of that here. Here also bituminous with this methane and this carbon monoxide oxide. And this. So when a coal, a lignite or a organic type 4 type 3 rich substance is getting decomposed, slowly and slowly methane is coming up out from through these reactions from that source. First one, it is called biogenic methane. It is within the less than 550 degrees centigrade, and if the temperature is greater than 50 degrees centigrade, through reactions, it is called the thermogenic. So biogenic total methane is your biogenic and thermogenic. As it is, we are discussing the coal-based methane. Achha. What happened? From coal, the methane is coming out. Just you see here that here is a break, and the methane gas, it is the resorption or adsorption, whatever it may be. I am coming later. So methane gas is coming out. It is the methane gas is coming out, and here it is the maximum. Now it is almost constant over here. Then there is a break where almost at a 0.8 or 0.9 reflective index, that your methane gas is coming out faster, and this is the area where we will get the maximum amount, maximum slope up to this. So from 0.8 to 0.9 up to 1.1 or 1.2, this is the area where from reflective index we can get that maximum methane we will expect from this region. So what we will tell? We will tell that if we are having a rock, we have seen under microscope, and we can determine that its thermal maturity or vitrinite deflectance level is 0.8 to 1.2. Then we will tell that it is a high volatile A to medium volatile rock, coal, and it will give you the maximum amount of methane gas if it can be used as your hydrocarbon potentiality. So this is very much important. I think you have got it, that this much of methane gas per cc may come out from these reactions, which is very important. Coal-based methane. Now the coal-based methane, it is afterwards I can tell you. Now one thing that we have seen, the vitrinite, liptinite, inatinite, all this. The coal is considered as a macromolecular structure, and it is having so much of aliphatic and aromatic rings. So some aromatic rings over here, aliphatic rings over here. So everything is mixed together, and it is conventionally it is the CH4, and if it is a double bond, we know it is a sigma and pi bond. So it is the pi bond is a very loose bond, and when it will be given energy, the pi bond will be splitted, and your this a double bond will give you a single bond chain. That means what happened? What I want to give you, it is a coal. Coal is like this macromolecular. With this number of these aromatic and aliphatic rings are there. But when rank will increase more and more, when rank will increase, just see, when rank will increase, rank is increases towards this direction, we are getting more and more aromatization over here. Here less aromatization, here more some aliphatic rings there. So these are the aliphatic rings, these are some aromatics, these are some aromatics, everything are juxtaposed, and it is like this. It's called macromolecular structure. Now one thing is very important, what I want to tell you from here, that when aromatization increases, then your maturity is also increases, that is coal is being more mature. So this is one thing. Now accordingly, inertinite should be more mature because it is inert, and all the things are your this macedal mass is more mature, and it is of your aromatic range. Vitrinite both have the aliphatics and aromatics. So there is a tremendous capability of this lignite to get the molecular arrangement change over increasing maturity. This is very important. And if it is lignite, what happened? Lignite, more of it is the aliphatic. Now you can tell me now that lignite, if it is much more there in a coal, then the coal is much more lipid rich. That means much more aliphatic chain rich. If it is much more aliphatic chain rich, then there is a possibility of getting some oil from that coal. At this point, I am not discussing, afterwards it is there. So it is the same thing. That is the for an anthracite coal. Just you see how it is, the aromaticity is coming on. So after this, the coal and its internal structure with respect to hydrocarbon potentiality, it is delimited. So if any question, please ask me or may ask me afterwards. Now I am going to the coal bearing formations or coal bearing Gondwanas are there, and Gondwana and lignite bearing those areas, that's tertiary, and those basins. And this is there, it is very small. This is the overview of the, yeah. Just you can see that some are circled over there. So these basins, these basins are Gondwana basins, where we are getting this whole scenes over there, and some over Rajasthan, over this Tamil Nadu, these are there. So here we are getting our lignites. Now, paleogeographic map of the Sakmarian state. Okay, so what happened? These basins in India, this is the main Gondwana basins. I am not going to this detail. You know, this is the Mahanadi Reef. Sorry, this is the Mahanadi Reef. This is the Mahanadi Reef, Godavari Reef. So Godavari Reef, and this is your. So what is it? It is the Son Narmada, and after that the Damodar Coel Valley Reef. So this is one, and another small reef is there. This one. This is the Rajmahal. So all these things suggest that they are in a collinear fashion or linear fashion. The Gondwana basins, where we are getting this our Indian coal. So now in the Indian coal, where it is there, where it is there coal and lignite in this way. So not all the coals and lignites are associated with your these gaseous phases. That means coal bed methane or gas. So just one thing I want to leave one thing, that just a minute. Okay. Now it is going on. Okay. Okay. So all these sedimentary basins are not associated with coal bed methane or the gaseous state like shale gas. Some basins are there, and some particular information we should have before getting some coal bed methane or gas. So up to this, we are we have ended the hydrocarbon of this type 3 kerosene for this solid fossil fuel, coal and lignite, and their disposition in India. Again, I will come to the disposition in India, basin by basin, in a very small way, not the very detailed one, but still, after this, we are going to the gaseous state. Gaseous state means this is a coal bed methane. Already we discussed something about that, that during the maturation of the coal, it is coal bed methane is coming out. Now, what is its utility and how does it will be used, and what is the hydrocarbon potentiality of that? Just you see this natural gas left one, it is the ONGC natural gas. That means petroleum natural gas, and the CBM here is the coal natural gas. So methane is greater than 95%. You can see over here, it is more than the methane within the natural gas over there. So and the heat value is almost same. So it is very much important in that respect also. So quest for CBM is going on to the USA, Australia, China. They have also done a very good job about that, and we are also after it, and we are doing our level based from the matured basins. We are getting the CBMs, and from the from some lignite basins also we are getting some biogenic methanes over there. So for the CBM, the main thing is that the coal is the source rock and coal is the reservoir rock. That means the same rock is acting as a source, as a reservoir. So during the formation of the coal, gas is generated and the gas is entrapped within the coal itself, and afterwards we will analyze the coal and we analyze that how much gas will be entrapped over there, and we can take a cognizance that whether that gas may be utilized at a hydrocarbon source. So for doing this, again some coal petrography is needed, and one of the very important part of this, that it is thermal maturity. Again, methane gas generation, we have seen it already in the table. Distribution pattern of different minerals, that is the compositional makeup of the coal. It is controlling the gas storage capacity, that is the coal petrography. And another thing is slit analysis. That means slit means fracture. Fracture within the coal, it is micro level. So these fractures is very much important for storage and your permeability and porosity capacity of the CBM, and for the CBM assessment. It is under the microscope. This is very much important. Now, for this, another very important thing is that methane gas entrapped in a coal bed is a joint function of coal seam thickness geometry, obviously. More regular geometry with thick coal seam, obviously a very good source of the coal bed methane. Depth will, if depth will be increased, more and more gas will be entrapped over there. So depth will be very important. Electrographic composition, just in the last slide we have seen that mineral composition, that is the vitrinite, lignite, inatinite percentage is very much important. And with that, the thermal maturity, the rank of the coal, that is also through the coal petrography. So these things are very much important. And the most important thing for coal is the storage of, for the coal bed methane, is the storage. Storage is the main. Coal methane may be formed, but if that will go out of the system, then it is not. It is not for our purpose. So we have to get CBM from there. So for this, the main important factor is the pore system. Just you have seen that within the macromolecular structure of coal, I have delineated earlier that the pores are there within the aliphatic, aromatic, and the inorganic components over there. Pores are there. Those pores are called in three types of pores: micropore, macropore, and mesopore. Oh, three. Meso is missing here. So micropore, mesopore, and macropore. Micropore, those are less than 1 nm dimension. This is called micropore. So micropore for absorption of methane gas in coal, it is very much important. The up to this micropore level, the gas will be entrapped, methane gas will be entrapped within the micropores itself. Just you see over there that micropores in coals, this is a coal, and these white dots are micropores. Within these micropores, what happened? The methane molecules are coming up, and they will be saturated over there. So monomolecular layering is being formed, then bimolecular layering, then the total molecule, total pore is saturated over there, and it is almost half saturated, nothing. So it is undersaturated. It is undersaturated with the molecule, methane molecule. It is totally saturated, and it is also undersaturated. So what happened? More and more methane molecules are there. More and more the micropores are being saturated, and this is an index, that saturation index it is called. That saturation index is telling you that what level, at what level the micropores are saturated, and at what level the gas is being utilized for prospective and for the utilization purpose. So this is very much important, the arrangement of methane over within the micropores. So for this, the two things are there. That is the methane may be absorbed over a coal surface. This is a coal surface. I can show that this is a coal surface. This is a coal surface. Over the coal surface, there is van der Waals force of attraction. The methane molecule are getting attracted. Physical absorption, or with the chemical absorption, sharing or transferring electrons. So these are the two types of physical absorption or chemical absorption. The methane molecules will be absorbed on the surface. Just see this phenomenon, adsorption. Very much important. All the methane molecules, it is not absorption, not AB, it is AD. So AD, absorption, is the two types. physical and chemical. And this is the coal surfaces. They have the property of this adsorption, by virtue of which it attracts the methane molecule, and the methane molecule are stored within the micropores. So that is very important. So it is adsorption. And the opposite of it, what should be? The opposite of it is your desorption. And opposite of adsorption is desorption. Desorption means to the capacity to which it can free the gas. That means if we heat it, if we depressurize a coal seam, if the depth of the coal seam is less, then it will not be saturated like that. Then again, what will happen? It is very important. Then what will happen? Then if the primary thing will be like this, then we will get from these primary things this type of things. So from saturated to undersaturated, from undersaturated to more undersaturated. So gas will come up. But as gas is entrapped within this, it is adsorption. Gas will be out of this, it is desorption. And this is just opposite. So if we can measure adsorption, we can measure desorption and vice versa. So if we can measure desorption, we can also measure adsorption, because these are the same. This is very much important. I am telling you, afterwards you can see. So now after this, what happened? That the fracture system, it is called cleat system. Number of cleats, bar cleats, it is not the way of doing it. Just you see that it is the coal seam, it is the Vitin mats, Vitinites are folded over here. Vitinite are tectonic effect and thrusted, and it is right past one another. So all these are the channel ways by which methane may be wiped out or passed out from the coal itself. You can see this coal. Within this coal, we are having so much fracture zones. These fracture zones, interconnected fracture zones, those are the cleat system called Bart and Face cleats. So these cleat systems are very important for passageways of methane in the system. So these Bart face cleats are there, and these are the actually they are the parameter. These are the parameter which is important for the permeability of the methane gas, because methane gas we want to get that methane gas from the coal, so we have to depressurize it and we have to get the methane gas out of the system. So we have to have the permeability path for that. So this is very important. If a very good fluid system is there, very good permeability should be there. Now under microscope you can see that these are in a vitrine man, this is the cliffs, these are the fractures, we can measure this, and this is an integral part of coal bed methane analysis. We have to have analyze these cliff systems under microscope, their frequency, their distribution, their height, aperture, width, everything. And these all have direct relation with the production of the coal bed methane in the form of a gaseous hydrocarbon. So just you see that the cleats are zigzag and they are anastomosing. They are almost one is jointing with another. So these are the crisscross fracture system. Just seeing the microscopic figure, you can tell me that yes, the second one, that this one is very much important for the permeability point of view. And this is also important, but this is not like that. Yes, both come hai not like that. This is also like that, but it is very important. So this can be pointed out from for CBM. Now here also it is also like that. That cleats are there, they are interconnecting, they are but they are filled up. There is no open space is there. All the these mineral matter or pyrites or whatever it may be, all these have engulfed the fractures within the cleat system. So it is the not the particular type of cleat that we are we should expect for a good CBM production. Cleats are there, but they are not that much permeable. So that is very important. Now measurement of the gas. What happened? Just I before going to that, I just want to give you one thing. It is here or not, I don't know. Okay. Okay. Just what happened? Now we are going to measure the gas. To measure the gas, some problem is there. Okay. Okay, just you see over there. This is the first one. This should be the first one. It has been swapped. I don't know. This is the what happened now the gas we want to measure the gas now there are some procedure to measure the gas this is not the platform of discussing all these things just you need to know that the gas will be measured in three ways. One is a direct measurement in the field with the drilling itself. Now it is going on for our exploration that is going on there for the shale gas. It is the same coal bed methane. I will discuss it later. So these things that is the dissolved gas that is called the measured gas. Some gas are lost that is called the lost gas. We have to measure it statistically, and some gas that is residual that will not come out of the system normally. We have to crush the sample. We have to powder the sample, and then we will have to measure the gas that will be entrapped within the pore spaces. So that will give the residual gas. When we will add all these things, it is giving you the Q1 plus Q2 plus Q3 and the total measurement of the gas. And this is some system in our field where we are measuring this dissolved gas. Now you can remember just that this is a bullet and pipette system. That is a beaker and pipette system. A bullet system. It is gas is coming. It is called canister. From this within this canister, some samples are there, and from these samples is a temperature control canister. Gas is coming, whether it is CBM or shale gas like that. It is going there. From the downward displacement of water, we can measure the volume displacement, and we can measure that volume afterwards, and we can take a note of that. And time to time, we should carry out this experiment, and the gas that is coming out, that is called the dissolved gas. Why dissolved? That is, if it is a dissolved, if it is coming out, then it should have not been absorbed earlier. So if it is absorbed earlier, gas is coming out, then it must come in your mind that gas should be absorbed there to get it dissolved. So we are getting the dissolving, but dissolved gas, that means the gas must be absorbed there. So when the gas will be absorbed, the gas will be absorbed, the methane gas will be absorbed during the qualification process. That means during the formation of the coal itself, at that level, it is entrapped within the coal itself. So that's why now we are getting that coal sample and we are giving that reservoir temperature through thermostat and we are getting gas. So from what the gas is coming? The gas is coming from the coal itself, from the micropores of the coal itself. So that means that is the dissolved gas. We are directly by measuring that. And during this coming out, some gas will be lost. So those lost gas is statistically we can measure it from this lost gas calculation. The detail I am not going to discuss here. And the residual gas, this is we are giving this is a Q3 road mill crusher. Here we will crush the sample, get the gas from here, and it is the lost residual gas. We will add it, and lost gas calculation it can be done, no problem. So these things, but in a very nutshell, that is the CBM, coal bed methane, is going on, and hand in hand, I am telling you, the shale gas system, shale gas is also like that. Something is there afterwards. But the main procedure is almost same for these two gaseous substances. Now here I am showing you that the Eastern Gondwana coal field, just you see that this Damodar Valley coal field and Rajmahal coal field over there. Here the Damodar Valley coal field, all the maximum coal bed methane, shale gas, whatever it may be, we are getting from this Eastern Gondwana coal fields. And in the Central Gondwana coal fields, they are at Swakpur. We have got CBM from there, and specific reason for that. And what is the possible cause? Possible cause is that here we are getting the abnormal geothermal gradient. That means normal geothermal gradient, if it is 3 to 3.5, we are getting high geothermal gradient over this Eastern Gondwana coal fields. That is near Jhoria, Raniganj, East Bokaro, West Bokaro, Karanpura, like this. This Eastern Karanpura coal field. That is there. They are getting high geothermal flow, high geothermal gradient, 5, 5.56 like that. So abnormal geothermal gradient has given rise to abnormal maturity of the coal and the cell, and the coal over there, as it is got thermally matured, as I have discussed earlier also, the thermal maturity is like that we have got high rank coal, and only from Jhoria coal field we are getting the primary coking coal from all over the India. Only primary coking coal, and only the coking maximum coking coal of India is coming from Jhoria right over here, right over here. So it is very much important over here, this is Jhoria. So here in the running ons also some parts are there. So this is a high heat flow over there. So this is one cause. That is why this is like it is like that. Why we are getting CBM and shale gas more like that. Just you see here, that is the Swapur coal field. It is approached by a number of ring dikes over there. So the heat has coming, abnormal heat has coming from the nearby ring dikes, and the coal has been matured with that a very high down thrown of a fault over there called the Bamni Silpa fault along the mid of the Central India Silchar zone. So it is associated with the CITJ, and it is giving you the 600-meter fault to the northern side of that fault, and the coal has been matured for that only, and with the ring dike also, and we are getting CBM over there also. And just this is just you see that the charged with CBM highly charged CBM water, it is coming out artesian, and when I I matched that is a click over there, and it is burning. So over this, just over this, it is burning. So just you see that the gas is coming out, and it has got tremendous capacity for using for a secondary, that is the that is what we, unconventional, that is your hydrocarbon potentiality. So it is very much important about that. And another thing is associated also with it. It is called the UCG, underground coal gasification. Nothing is there. I am not going to that detail. So those who are interested with this unconventional that is your source of unconventional source of energy. Just 2 months back, I have I published a paper there in the Springer Nature. It is there. The link is also there. If you are interested, I will give you the link. It is there that all the Indian scenario, Indian perspective of the unconventional energy sources, I have given a overview over there. So underground coal gasification, it is nothing like that. That it is that the coal seams. That's the essence is that the coal seams which are far beyond depth there, we cannot excavate that. So go for that coal seam for additional energy source, hydrocarbon potentiality. So at that level, go for ignition of that coal, and from that coal, that the methane will come out, and we will trap the methane, and we can go for the alternate source of energy. So that is very important, UCG. I am not going to the detail here. Now coming to this is the last one, possibly this hydrocarbon fossil fuel. This is the coal to oil. Now what we are seeing that from coal, oil is trickling down, and this oil is directly pouring into a car. So, so this is not really the situation, but this is a hopeful situation, and it is we always hope there after this awakening from this pandemic, we can do something for this, and we are right in that direction. So it is very important. All over the world, it is going on. So coal to oil or coal liquefaction process. So after gasification, this is called liquefaction. Just you see that we have given you one idea earlier that one axis y axis H by C and the x axis O by C. That is the type of kerosene. In that type of kerosene, I told you that type 2 and type 3 kerosene. Type 3 kerosene is for your coal. But if a coal is much enriched in hydrogen, then how it can be enriched? Then your H by C ratio will be enriched. Then how it can be enriched? Because the coal may be aliphatic rich. That means that the rings that are not that much of aromatic. How it will be aliphatic? That means the coal must be enriched with your liptinite mineral. So Maceral indicates that liptinite Maceral indicate that yes, if any coal is rich in liptinite, that is very suitable for this coal to oil, because oil is also enriched with your fatty acid, fat, and your coal is also enriched with your liptinite. This coal is enriched with your fatty acid. So there is a possibility of getting this coal to transform into oil. So this is very much important, and very research work and the other plant level work is also going on for this. And for this, the vitrinite reflectance value it is given, the coal should be less matured. Why? If it is more matured, more vitrinite will be there. If it is less matured, kryptonite will be there, and more aliphatic chain, that is your straight chain, side chain will be there. Less aromaticity was there. So less rank coal will be very much important for that. So these things are very much important for your petrographic study for conversion to coal to oil. Just you see the diagrams. All these under your ultraviolet light, and you can see the total field is covered by your liptinite macerals. So obviously, this much of liptinite means this much of lipid or fat. That means the coal is enriched with your liptinite macerals or your aliphatic fatty acids. So those aliphaticity can be converted into oil, and we can get oil from that coal. And exactly what we are doing these things from different types, different coal fields from India, and we are getting this value. Just you see here that these four colors are nothing that vitrinite, liptinite, inatinite, and cell or mineral matter that we are seeing a coal under microscope. The red marks, the red bars, they are liptinite. Just you see here that some your coal seams are very much enriched with your this liptinite. So those coals may be used for this conversion. So conversion has been made in the CSIR Simphar lab at your Dhanbad. They have coal to liquid plant, pilot plant, and just you can see that I am holding a bottle that is your very much optimizing that it is the oil is coming from that coal, and this oil is just you can see. If you can see here that you can see that calorific value is 10,899 kilocalorie per joule, and from the coal from where it has been taken, it is only 5,000, approximately 5,000 kilocalorie per kg. That means calorific value has been doubled over here. So it is very important, very ultra clean fuel. This fuel can be directly poured into aircraft also. So that much pure it is. So we are working over that, how it can be more economically viable it can be afterwards. So it is very much important in that respect. So it is not a fiction. It is not an enigma. We are doing it, and right now I am holding it. So this is the thing. It is another source of hydrocarbon where the coals are not suitable for other uses. That means where the coals are low rank coal, there it can be very useful to get oil from there, and it must be very effective for expensivity also, because economic viability should be there for use it in a plant or in an industrial basis. So research is going on in that domain, and we are also finding now that not only liptinite rich, some vitrinite rich coals are also, those are earlier it was inadvertently taken that no, it was not suitable for the coal to oil. Now we are seeing through the molecular study of that coal, no, it is not like that. Not only petrographic study, molecular study tells that yes, those coals are also suitable for coal to oil. So this is very much important. I am. We are on the threshold of this. We are doing some work. Let it be completed, and then we will be a position to get it. But now you can see that coal, that oil I am handing over here, that it is coming from a coal, that is coal from running on coal field. Running on coal field, that coal is obviously not rich in liptinite. That is a vitrinite rich coal. That too, from 4 tons of coal, from 4 tons of coal, they have got 1 barrel of oil. 1 barrel means 160 liter. So that much of coal, 4 million ton, is giving you 1 barrel of liter. So if it will be a liptinite rich coal, I have given them the guarantee that you can obviously it will be double or triple if it will be from the other areas like your Rib River coalfield, Talchir coalfield like that. Those who are rich in your liptinite varieties. So this is very important. So after that, the visible light is over. Within this visible light under petrography, we are seeing this. So we are seeing now under the infrared regime and the infrared beyond liptinite, we are getting to the molecular level. We are giving to this bond. You are getting this the middle figure. It is rotating. It is actually the multimolecular structure of a coal, and the covalent bond is just bending and stretching like this. So depending on this, we are going to the infrared spectroscopy to get the spectroscopic evidence from that. And we have seen that the different types of spectroscopic evidences are coming, based on which we are getting this type of signatures in the infrared spectroscopy, the term called Fourier transformation infrared spectroscopy. And for each and every level of that is your inertinite, vitinite, nictinite, we have got different signatures, just like XRD. For different coals, we are getting these different types of signatures, and we are getting that fact that functional groups, the covalent bond, the double bond, the triple bond, the single bond, and the nature of the bond, that by which it can be transformed into easily into coal to oil liquefaction. So this is very much important, and the works are going like towards this. Now shale gas is that gas that is entrapped within the shale, and up to this that is over. I am continuously checking is because that it is the same thing as your coal bed methane. Only thing, it is entrapped within the cell associated with coal and the petroleum. This is very much important because the cell we are seeing in the field that we are usually giving two terms. One is your gray cell, another is your black cell. Gray cell means the cell is not having that much of organic matter and not black that way. But black cell means it is carbonaceous cell. It is more carbon enriched is there. So those cells are there, and within the cells, the carbon materials are there. So whether that cell may be utilized for getting the gas from there or not. The same thing as the coal, it is the cell which are giving you the gas, and the gas is entrapped within the within the periphery of the cell, because cell is a very tight one, and it is actually it is called, the cell gas is also a term is there called tight gas. So it is there because to get this gas we have to fracture the cell. So it is a very important part, that is the fracturing of the cell, and after that the gas will come. But the procedure is same. The property by which it has been entrapped, it is same. Just you see that all in the R&D activities are going on. Not only that, and with that the industrial use of the cell and CBN gas are also in vogue. So all these cells, starting from your Vindhyan, last I was telling earlier in the morning that Vindhyan basin, we are this is some potentiality is not there. But I told you that with the carbonate sediment there are some black cell is there. So now people are going after that. If black cell is there, whether that cell can be diffracted for the cell gas or not. So this is hydrofracturing is a very important parameter, and for the cell gas character of the cell, it controls the gas storage capacity and production. Thermal degree of the same thing, just you see over here, that is the degree of thermal maturity of organic material. This is very much important. For this we are going for the total organic carbon pyrolysis analysis, rockable pyrolysis like this. As you see, the properties, that is a thick carbonaceous cell should be there. Total organic carbon must be greater than 2 or 3%. Thermal maturity of the organic matter, you know it now, reflectivity 1.1 to 1.4. I have shown you earlier in that table. So moderate clay content 40%, in situ gas content should be marked, and it is very important, the last one, brittle composition. The cell should be enriched with quartz. If it is a quartzose cell, that is the, if it is an that is the arenaceous matter is there, quartz is there, then it is much more easy to frac it. It is the hydrofracturing is much more possible. If it is not like that, if it is malleable, if it is kaolinite, if it is elite, monomerilonite, the like that, the clay, it is something, some problematic is there, because once hydrofracturing will be there, then again the fractured part will be get closed by the swelling capacity of the clay. But if it is more brittle composition, it will not swelling and the gas will come out from there. So prospective shale gas deposits in India, just you see the Gondwana, Kambe, Assam Arakan, KG value, a KG basin, it is the Kaveri and Godavari, Krishna Godavari. Kaveri, Rajasthan, all these things are there. So over these areas, we are searching for the prospective shale gas analysis and going on. And from our GSI, right now, only in the only sole exploration activity is going on in Jhoria coalfield. What I have shown here, just you see that Gondwana, in Gondwana we are giving just here. It is in the Jhoria coalfield here, and in the, I know in our in these training mates also, I am having our cell gas experts. I can tell them the cell gas experts, they are there because they are associated with this cell gas exploration over the years, and they have done a splendid job over there. In this pandemic condition also, they are going to the field and measuring the gases, and exemplary evidence they are setting over there, and exceptional value of gas is coming out. And yes, it is a very interesting domain that where India can flourish in near future. So these with the boreholes we have given over there, this is the, just you see, I am giving you some just one idea. This is what it is. It is the Damodar Coel Valley Basin. Just I have shown you there. And this is the Jhoria Basin. This Jhoria Basin, it is here. So from Jhoria Basin, it is the central part. From central part, it is covered by the Raniganj. It is the most deepest part of the basin. It is your Bodakar, Baden Meza, Raniganj. That means it is the central part. The central axis is going like this, and we are giving our boreholes over there. It is completed over here, and now we are working over here. So here also we are getting tremendous potentiality of this shale gas factor, and just I am showing you that with this shale we are coming from the two important shale horizons. One is called carbonaceous shale of Horiarpur shale, and another is Sivabuti. Two main shale horizons. These one and these one. These two main shale horizons, very thick shales, thickness almost 95 meter total. Thermal maturity, just you see, it is well within the range of the matured gas level. So we are getting the gas window there, and we are getting tremendous gases. So this is going on activity, and I have just given a glimpses of this boreholes going on there. SG is shale gas, and CBM is the coal bed methane associated with the coal. So all these things we are measuring the shale gas and the CBM part, and we are getting the a reservoir over there. So rockable pyrolysis of the cell samples has been done, and the most important thing that we are getting these values. Hydrogen index, this is some S1, S2, S3. It is not the platform of doing it detail, but still due to the some heating effect, some free hydrocarbons are coming out from the cell and the cell samples, and we have measured it, and the amount has been measured, and from that the hydrogen index, oxygen index, it is given here. All these things are measured, and all these things are giving these values are telling that the very oil prone of gas generation of this domain. So this basin is very much important. So it may be used everywhere in every basin to get the hydrocarbon potentiality, whether the gas generation capacity is there or not. So this is going on in the field, as you see, and it is taken out, drill core, pouring into canister, gas measurement is going on. The same thing we are doing for our CBM, and we have seen that in our CBM that the gas is giving out is measuring from this one. So these things are totally same, and all these things, just you see that it is adsorption isotherm capacity. This is just reverse of that desorption, and this is a very good criteria for the productivity point of view, that at what amount of pressure is to be dropped, and what is the your Langmuir pressure, Langmuir volume, all these things. And ultimately we will get the GIP, which is the most important to us, that is the gas in place. This is the resource value we are giving to the nation each and every year. So this is the very important thing for the shale gas reservoir. And by cross plots of all these, that is the Tmax and the or Tmax means it is also from this rockable pyrolysis. It is coming. So what we are seeing, we are seeing that it is coming is the post mature and the mature to post mature. This gap is there. There is a very well matured zone. It is coming. Just you see that in this domain it is coming, and here also it is the gas prone. Just you see it is a gas prone or oil prone. In the gas prone zone it is coming. Here it is coming in the type 3, type 2, type 3, that is transitional zone. That means it is well zone, well for the well prone for the gas. And these things are you can plot it everywhere. And with the depth, the gas is also increasing. You can see. Okay, it is again. It is going over here. So these things are sorry. Just a minute. Okay. So up to shale gas, it is okay. It is completed. Now I will give you, just you see, need not discuss. Just you see that some glimpses of the of our these coal bearing Gondwana basins. Coal bearing Gondwana basins are here. That is that in the rift system. Just you see, these are the pattern. Umanodi, Godavari, Damodar, Koel, you know. One by one, if I am coming, just I have put it here just for one reason. You can see that the internal structure of all these basins, all these sub basins, the internal structure are followed by the external major structural units. These are the main important thing, and the basin also evolves or develops like that. What it is your the major Damodar Valley Gondwana coalfields. Damodar Valley, one after another, Raniganj, Choria, Bokaro, South Kodampura, North Kodampura. The total internal structure and the major basement fracture system is like this. You can along the lineament, we can see. So need not to discuss. So one after another means now I am going Jhoria, running on. Just you see the external structures are going. External structures are going like this. Again here it is. Again the main system is like this, no problem. But there are some faults over these and some faults over these. So these are the cross faults which are actually control the deposition of the coal seams. All these black lines, those are the coal seams. And you can see there is a separate depot center here, there is a separate depot center here. So here the depot centers and again over here. So these depot centers are different and different based on the what is that? Based on your cross faults. So major faults are there to develop the basin, evolve the basin, but the cross faults are there to develop the behavioral pattern and formation of the coal seam. This is the most important factor, and possibly you know I am just giving you one hint over there that if there is a ellipsoid like this, if there is stress ellipsoid, if it is the main stress system, that main fracture system, then obviously your direction of stress is that way. And if it is like that, two conjugate system will develop along this and this at apart 30 to 35 degrees centigrade, which are actually called the line of no transformation. So this is actually the fault system which are developed over here and here. So these systems are very important for getting the behavioral pattern of coal and the formation of the coal, formation of the basin, subsidence of the basin, and all these things will go at an optimum rate only because of these conjugate faults and these criss-cross faults. So to develop the basin, to develop the coal seams, the coal formation, the main role is played by these cross faults, and to develop the basin itself, to enlarge the basin itself, the main faults are the east-west or west-northwest, south-southeast, main trending fault. Possibly it is clear, just you see over here. Another example, it is the Bokaro coal field, East Bokaro coal field, and here the fault system is this, and these fault systems are responsible for the coal seams over here. Next, here, you need not to tell, just you see, all these are these fault systems. Huh? Okay, and the coal seams are also in this shown. Just you see, I am giving you the pictures. South Karanpura, exactly same. Everything, depot centers are different, and these are the cause that effect from the effect of the cross faults, and most of these are primarily determined as the thin sedimentary faults, and that's why the basins are subsiding. That's why the coals are forming. That's why the coals are preserved, and we are getting this type of depositional pattern like this. So South Karanpura. Then this is a different one. This is Rajmahal. Earlier also I have shown you that the Rajmahal coal field was there, and all the coal field strains are like that. But your Rajmahal is north-south. It is the north-south. Why it is north-south? Possibly you know. Just a few words I am telling you, because the rift system is north-south, and through the rift system, enormous lava has come out. That is your Rajmahal trap. The Rajmahal trap, you have seen the green one. The red one, pink one is your this small one. I am giving the larger one. So this is your basement, and this black one or gray. These are your boracots. These are your sedimentaries, and the total this part is sedimentaries. It is covered up by the Rajmahal group of rocks. What happened? The popular notion is that there is a plume called Kerguelen hot plume, Kerguelen hot spot along the 80-degree east ridge of India over here, along which the Indian plate has overridden in the northeast or northeast direction. If it is overridden, then the fracture system is coming like that, and along that the Rajmahal basalts have come out, and with that, within this fracture system, the fracture system prevailed there as a north-south fracture system or north-northeast, south-southwest fracture system. And we are also getting here that yes, the fracture system that control the coal formation is like this, but another fracture system here is like that, and it is exactly the same fracture system as like this one. It is the Damodar Coal Valley. It is the hidden fracture system. It is not that much of evidence, but the main evidence system is there. So this is according to your Kerguelen hotspot and Kerguelen hot plume, and it has been dated back. It is dated. Absolute dating has been done through SMND parameters, and we are getting the lowest value. That is the lowest H from here and highest H from here. It is 130 to 132 million year, and it is 103 to 105 million year over there. That means the Indian plate has overridden. It is the youngest one, and it is the oldest one. That is the leading edge, and that is the trailing edge. So that is the normal notion. And in the Swapur coalfield, now I am coming here just in the central part of the coalfield in India. Here in the central part of the India, we are having Singrauli, Tatapani, Swapur coalfield, Gilimili coalfield. All are Son Valley coalfields are normally termed Son Valley coalfields order here. Just you see that the main fracture system is this. That means along the Son Narmada shear fault, shear zone. That means CITJ, and the other ones are here also. So this is the normal scenario we are seeing everywhere. and here within the itself, within the coal field itself, I was delineating just after a few slides before that a ring dike is there. This is the ring dike. The total has not come. This is the ring dike, and we have got CBM over here. We have got a fault called Bamni Chilpa fault. It is the throw is 600 meter towards north. Just you see the throw, and it is actually the fault which is a part of the South Narmada shear zone or South Narmada zone fault, and it is a part of the Tangavilgarh Songod, and ultimately the CITZ, that is CISZ over there. So it is very important. So all these things are maintained, and it is a Singrauli coal field. Here also we are getting the cross faults. Not all are marked over here. This is an old map, so all those faults are not marked over here. And this is a those who are very much interested. This is a book by Dr. Subramsu S.K. Acharya, Tectonic Setting. It is the Elsevier publication, just 1.5 year, 2018. Last it is published. There is also a and the front page is is a, from one of my paper. It is it has taken. It is the Tatapani Ramkola coal field. I have marked the lineaments over there, the main faults, the subsidiary faults, everything. So it is over there. And Son Valley Basin Sedimentation Tectonics Unit. So there the paper is there in that book. We can take it from there. It's this Tatapani Ramkola coal field, the shear zone. Just I have told you the Tatapani shear zone, it is there. Tangavilgarh shear zone, and within this coal fields are there. And I have put forward the model. It was proposed that it is the spool apart basin model that I have told you earlier. And applying that model, we have got tremendous amount of coal over there, which have given the GSI another National Geoscience Award. So it is associated with that. In the Talchir coal field also, here, just you see, it is the northwest, east, northeast, northwest, southeast, and here Talchir coal field is there. The main fault is also there. The main fault is like this, no problem. But the cross faults are also equally over there. The cross faults are there, and they are the very important for this coal development. And here also another in the Ib River coal field, just you see, here is the Talchir, here is your Ib, and these coal fields are really important for your coal liquefaction process, because the coals are very much important in liptinite. So here also one of my paper is there, and here we have seen that the cross faults are maximum. Just you see the cross faults. That's why the stain ellipsoid model come. So these are the cross faults. It is maximum. The minimum are the major faults. That is along the basin. So this is very important. And one gentleman, Chandan Chakraborty, if anyone interested, he can go with this paper. It's an excellent paper. He has done some laboratory counterpart of these basins, and with the sandpack model, he deduced these fracture systems, and it is almost matching with all the systems of this our coal bearing Gondwana coal fields. So, and it is suggested that all the coals over here, it is not faults are not post depositional. Faults are majority faults are same depositional while the coals are forming. Now going to the Planita Godavari, that is the same. The coals are there here and there, some in the north and eastern part, and your fault system. Just you see series of fault system. I have just give you this idea. I am just giving you this idea that along the rift, the Godavari basin has evolved, but coal has been evolved along depending on this fracture system developed later during the same depositional system. So that's all. So now in the northeastern part, we are having some In the Meghalaya, some northeastern part we are having tertiary coals. Gondwana coals are over. Now it is the tertiary coals. Tertiary coals in here and there. We are getting these tertiary coals in the Meghalaya, Arunachal Pradesh, and this Nagaland, and the base of the Arunachal. Everywhere we are getting it, and some Gondwana coals are there at Singlimari. I'm not going to that detail. It is the lignite occurrences there, and the workable deposits over Rajasthan and your Tamil Nadu, and type-wise distribution of Indian coal as on last year, 1/4/2020. Just you see that the 3.44 billion ton, 3.44 billion ton as on 1/4. Hydrocarbon potentiality is that the thick seam 0.90. Those were there. One of my colleague Prithibas is there. See, he was associated with all these things. He is also taking this training, and they have done this, and this is the 3.44 million ton up to last year, and with this the 3.42 of the Gondwana and 1.6 of from this tertiary coal fields. So tertiary coal fields is less, So Indian non-coking, the non-coking is almost 70%, 70.3% non-coking, and the rest is high sulfur and coking, medium coking. So depth-wise, it is the depth-wise distribution. Not going to those details. This is not important right now. Lignite is also that. So in the lignite-bearing basins of Rajasthan, some basins are there, and just I should see after that. Okay. After that, the basins are coming. Okay. So some basins are there. Jaisalmer, Bikaner, Chiru, Sanchur. So some basins are there. Within these basins, the lignite-bearing, the lignites are coming. And we are exploring those basins, and in the Gujarat also, in the extended Kutch area, or this Kutch and this Amrali and the Bhuj area, here we are getting some lignites. What there? So lignites in the Gujarat and Rajasthan, not that much, but very important in the hydrocarbon potentiality point of view. And in another, it is very important in another domain, that it is associated with oil. It is, as it is associated with, it is lignite, and the same stratigraphic variety, in the same stratigraphic domain, we can expect oil from the offshore part. So this is very much important in that domain, Rajasthan and then it is the Tamil Nadu. Tamil Nadu, there are two main basins. One is the Neyveli basin over there, and another is the Ramnath basin over here. So this is the Neyveli, the famous one, and this is the Ramnath basin. So work is going on from here also for the Tamil lignite, and that Tamil Nadu is giving much more than Rajasthan, because just you see, this is the Tamil Nadu. This is the first one is Tamil Nadu. The peak is almost all the lignite resources coming from the Tamil Nadu. So this is one, and after that, the category and this much of basin. So is it? Hello. Any question after this, and then I will go to the last part. Hello.
Anyone having any question or doubt, they can ask.
And then just I will take 5 minutes and again start, and I will finish. Is it? Because as it is some domain, it has to cover the petroleum also. So something has to be delineated, because hydrocarbon cannot be completed excepting your petroleum and gas hydrate. That's why I will take another half an hour and I will complete. So if any question, please. Otherwise, please give me 5 minutes and again I will come back. So please, any question?
Hello. Am I audible, sir?
Hello, Omnath.
Hello.
No, sir. This is I think Arnav Sengupta is speaking. I think he will ask some question. Yes, you are audible. You can ask.
Sir, in one of your slides, you have shown that in Sohagpur coalfield, you have traced in a fault, the name of the fault, and you have mentioned that it is some artificial condition is there. It is artificial condition is there, with especially with CBM, and you have mentioned about ring dike. So I want to know, just I'm not getting how is called ring dike is ring dike and sheet dikes. This I don't know how it is related to this. Can you explain, sir? I want to know how it is related to the CBM outflow.
I am going to that slide of the Swapur coalfield. Okay, okay. I am going to that slide. Please explain me in that way. I cannot get you. Because some sound is problematic. Okay, please once more, please. Please.
Sir,
This is the Swapur
no,
coalfield.
this is yeah, this is the Swapur coalfield, and the cross fault. Where is the cross? Uh, but and where is the ring dike? You have marked ring dike. Yes,
What
like
is that?
ring dike.
Okay. I am marking. Actually, what you can see here, that there is a dike system over here. Okay, this green part, this green part, and it is like this. It is like this. I am not going to the northern part. Okay, so these are the ring dikes, and just below the ring dikes, the Bamni Chilpa fault. Possibly you know it is there. Okay, so here we are getting the CBM. Reliance has also explored this CBM way back in 2007, 8, like that. So that is there, and there are two options. What I am telling you, that one is that thermal maturity should be there. So why it is thermally matured? To get that coal bed methane from there. One part is because to get the coal bed methane, we have to have the coal maturity over there. Right or wrong? Is it clear to you? Hello? Hello? Hello?
Mr.
Hello?
Arnab, can you hear?
Hello, Arnav? Arnav, is it clear to you? Arnav, he is in the
Maybe network issue, sir.
Arnav, are you listening me? Hello?
Hello.
Arnav, can you?
Hello, sir. Actually, there was some network issue from my end. Some network issue. Now it is okay, sir. Now it is okay, sir.
Okay. I am telling you.
Hello.
Now the ring dike.
Please, sir. I'm sorry.
It is here. The ring dike is here. It is okay. No problem. It is the ring dike. Again. One. This is here. Another is here. Okay. So this the total integral part of a ring dike. It is all the dikes are towards this. The inclination towards this. So this is one part. Another is like that. I have not shown the upper one. Just I am showing the lower one. It is the ring dike system. Okay. Can you see? Or no? Again? Can you see?
Yes, sir. Yes, sir. Yes, sir.
So these dikes are ring dikes. Okay. And a fault is going there called saddle fault. Okay. And the main fault, it is written as saddle fault. The main fault, it is the Bamni Chilpa fault. You know possibly. The very famous fault because down thrown is 600 meters towards north. That means a tremendous frictional heat has come up, and the coal has gone a certain at a level of 500 to 600 meter more depth there, and with the aid of the ring dike, this heat effect, the coals over there. Now 4 coal seams are there, 1, 2, 3, and 4. So number 3 and 4 coal seams are getting more mature. If it will be more mature, more methane will come out from there due to thermo.
Yes, sir.
And these coal seams are capable of giving you the CBM, and this CBM has already been exploited, and production has already been done by your Reliance over there. So Reliance has got so much this productive oils over there, and they have got. But after that, when they are going to the eastern part, no such horizon, no such coal maturity over there. Why? Because we are going away from this this Bamni Silpa large fault, which is a part of the South Narmada zone fault. Can you get it?
Yes, sir. Yes, sir. So, yes, sir. Yes, sir. Yeah, I have understood. Sir, so that is the reason, because for this reason only we are getting that abnormal geothermal gradient.
Exactly. This is the only reason we are not getting. I have worked Swagpur coalfield from west to east. Everywhere I have got 6 reports from there, but nowhere we have got this much. And another thing I want to share with you, that in this project, USGS, United States Geological Survey, is associated with us, with me, for 3 years, and we have gone tremendous high resolution work over there, and nowhere we have got this much of thermal maturity that we have got. From here and there we are getting, no, it is the thermal maturity value only zero point 0.5, 0.4, it is also there, 0.6, but here it is more over 0.9, 1.2, 1.3 like. Okay,
Hmm.
so that
Okay.
is the thermal
Okay.
maturity.
Thank you.
Okay. So, yeah.
So when we can start the remaining part, sir? After lunch or?
No, just a minute. It will not take so many times. I will
Okay.
as it is, because if it will be finished by another half an hour, I think it will be better for me.
Okay.
I-
Okay.
Any problem from the training mates? Just you, or otherwise I can take a letter. No
So
problem.
better to finish now, before
Uh,
lunch. Better to finish before the lunch. Continue the class.
Acha. Before the other training mates, please. Collective wisdom. What is that? What is the collective wisdom? Just please tell me, and then just after 2 minutes, I will again start and I will finish. I am telling you, because the last part is remaining in the form of petroleum, which obviously it is from your ONGC. It is not GSI's work. It is ONGC, but I have to delineate. So that is the thing. You must know it here and there. Okay. Should I start after 2 minutes?
Okay, sir. Okay. You can start after 2 or 3 minutes.
And then within 2:15, 2:20, I will come to you.
Okay, sir. Okay. Thank
Okay.
you. Okay.
শেয়ার এখন করতে দিচ্ছে না হচ্ছে ওরা বললে তার হ্যাঁ হ্যাঁ ওমনাথ
Yes, sir. Yes, sir.
should I start?
Yes, sir. Yes, sir. You can start, sir.
আচ্ছা is it visible that here slide?
No, 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 sir.
Slide is not visible, so I have to share again. Share. So,
Yes, now it's coming. Yes, sir. Came.
okay.
Yes, sir.
Okay. So now, friends, then the last part that is the petroleum part. According to the petroleum, your ONGC has earmarked that category of basins based on the petroleum generation. So petroliferous basins are normally categorized into 4 types. One is category 1, the petroliferous basin which proved hydrocarbon reserves and commercial production are also in operation. So this is the category 1. Category 2, that is the highest confidence level, category 1. Category 2, second confidence level, that is the sedimentary basin, proved occurrence of hydrocarbon are there. The hydrocarbon, that is your petroliferous basins are there, it is proved, but no commercial production has yet been obtained, or yet been started. Category 2. Category 3, with no significant oil and gas, but geological perspective of like that they should have some potentiality. So that is the category 3. No significant oil and gas, but which on geological consideration are considered to be prospective. And category 4. Category 4 is the petroliferous basins with uncertain prospects. With required data has not been generated right now. Analogy is there with the other hydrocarbon producing basins, but it is not proved right now. It is prospective. So there are 4 categories, and with these 4 categories, here it is under the category 1, it is 5. Under category 2, it is 5. Sorry. Under category 3, it is 4, and under category 5, it is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. 9. So then all total it is 9. All total it is 10, 10, 9, 23. So 23 sub-basins that we have declared earlier that they are the hydrocarbon basins, it is matching with this. So category, the 23 sub-basins based on the hydrocarbon perspectives, ONGC has categorized like this. So category 1, Andaman Cell, Assam Cell, Bombay, Kambe, you know it, KG and Tripura. Category 2, Andaman Nicobar, Himalayan foothills, those foreland beds, foreland, Jaisalmer, Kutch, Mahanadi. Category 3, Bikaner, Nagpur, Nagaur, Kerala, Lakshadweep, Saurashtra, Bengal, West Bengal, and category 4, all these the other here are coming. So these are the categories. We will know that a few of these category 1, category 2, category 3, and category 4, what actually they are telling, and what should be the structural and the tectonic implication for that. Just you go at the sedimentary basin map of India. Here, what we have got there, that the category 1, this is the category 1, category 2, category 3 and category 4, these are marked over here. You see, there's category 1, this orange color, here, of this orange color. Category 2, that is the identified prospectivity. Identified already proved, but commercially not started. So these are these areas. This pink, these here, and here also these. Some parts are over there. Then category 3, there is the yellow parts, prospective. Category 3 means this one, here, this one. So here also this one,